Perfect. Okay, was there anything we wanted to go over before jumping into the quiz?
I think we just should, I don't know.
Or you think we should just jump into it?
Let's just jump into it. We seem to do pretty
What
good.
do you guys think? Is that unanimous? Everybody cool with that?
Yeah, good for me.
Okay, well, I'm going to open it then.
I had it all ready to open until I went looking for the other quiz that Kathy was talking about.
Sorry. Sorry.
That's okay.
Calm down. Okay, has everybody got it open?
Yep.
Yeah.
Mine's still loading.
Okay. No worries.
Okay, I'm ready now.
Okay. So number 3, the symbol for the true population proportion is which of the following? I got P, just regular P.
ADC, yeah.
Yeah, C, P, C, whatever.
So the requirement.
The requirements for constructing a confidence interval are satisfied. I guess for the next 2 questions, suppose n equals 100, p equals 0.25, and p hat equals 0.10. Question 4, the requirements for constructing a confidence interval are satisfied, true or false?
That's true.
Yeah.
So I think this was one where I got confused sometimes. If it's the confidence interval,
It's,
are we using P or P hat?
Confidence interval, I think, is the one where we use the p hat. Let me see.
Okay. So that's going to be exactly 10, but that's equal to or greater, so we should be good.
yeah.
Yeah, we should be good.
Yes, the confidence interval is p hat. The hypothesis test is p.
Okay. I would say 5 is also true.
Yes, I agree.
I agree. So,
And then, study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. That'd be kind of a scary sample to take. As 45 of the defendants were found guilty. I don't want to live there. Find P hat, the point estimate of the population of first-degree murder defendants who are found guilty in this state.
Yeah.
Would it be 45 over 60?
That's
Yeah.
what I think. So 0.75.
Oh, yeah, obviously, yep. You're a genius. With them at 0, or does maybe it'll add the 0 3 decimal places. Buster. Okay. Create a 95% confidence interval for the true proportion of first-degree murder trials in the state. the verdict is, I think, where the verdict is guilty. Input your answers for the margin of error, lower bound, and upper bound. Determine the margin of error for this 95% confidence interval. Now, can we use the spreadsheet on this one?
Yeah, I think so.
Yeah.
Yeah.
I'll find my spreadsheet again.
So margin of error, I'm getting 0.10. Ooh, it rounds. I guess 0.110.
I got 0.11.
So what would you put for the null hypothesis? Just zero?
We don't have that information yet.
Right. So I didn't put that in. I just took the upper bound minus the lower bound and divided it by 2.
Oh, it's the same no matter what.
I think.
0.110 or whatever.
Yeah, that's what I got.
0.110.
Yeah, is that what everybody else is getting though? Because
That's what I got. Yeah, on the spreadsheet. Did you use the spreadsheet?
I used the spreadsheet to get the upper and lower bounds.
And then you divide that, right?
Yeah, I subtracted the lower from the upper and then I divided by 2.
Okay.
So I'm in a hotel, so the internet connection is miserable here because I'm getting about every third word. So in the spreadsheet, tell me what you guys did in the spreadsheet.
I
You're
just
on the one.
put it in to get. I just got the upper and the lower bounds on the confidence interval.
Okay, so on the one, are you on the one sample t-test tab?
Yeah,
And the variables.
one portion.
The one portion.
No, the one per portion.
One portion.
Yeah, it opens up to one sample z-test for proportion.
Yeah, it does. Okay. So for
Gotcha.
X, I put in 45 because that's the number of that were convicted. And N is 60.
Gotcha.
And then you take the 0.640 minus the.
I did 0.860 minus 0.640. So that comes out to 0.22, and then divide it by 2, you have 0.11.
Yep. So 0.110.
Yeah, I just put 0.11.
Okay. Just round to 3 decimals. So the lower bound was the 6.640.
Yeah.
And then, well, question 8.
Right.
Okay. If we increase the size from 60 to 80,
I'm putting a decrease.
it decreases? Yeah.
Yep.
That's what I got too.
Oh, gee.
Yeah, that's what I'm figuring out.
Question 11.
Yeah, I'm trying to see if I can figure this bad boy out.
Mm-hmm.
Well, I came up with 20 for both sides. So am I wrong? That should be right.
No, that is
Sounds
right.
right.
Okay, I think I'm back for a third attempt. And I think I'm going to leave my video off because that might be hogging all the bandwidth. So sorry.
That's okay.
All right, how far did you get? So I got stuck on 7. I'm on 7, 8, 9.
Okay. So 7, did you hear how we came up with the margin of error?
Yeah, tell me the name of the spreadsheet that you're using.
It's the new one that we got, the copy of categorical data analysis hack.
Got it. Yeah, I think that was my problem is I opened the wrong one. Okay, so I'm opening that and I've got it open now, going to one proportion, and I'm grabbing the X. You just use the X and the N from the previous question, right? From
Right.
question, whatever it was, right before 6. So X was
Right.
45, N was 60, 95%. And so then you're taking 0.64 minus 0.86 divided by 2.
Right.
Okay.
And make sure you use absolute value.
So yeah, so 0.11 is 7.
Yes.
Okay, and sorry guys, and then the upper bound and lower bound are, I don't even see those in here.
That's what you just used.
Oh yeah, the confidence interval, duh. Okay, I'm with you. All right, cool.
Okay, so then for 10, we put that it would decrease the width.
If you increase sample size. Yes, okay, got it. Because the more you yep, I'm with you on that.
Okay, and then for 11, we came up with 20. And that's as far as we are.
And 12, shouldn't that be 100?
I got 11.111 because you do the second one for that and it comes out to 11.111. Wait. What is the smallest it can be? No, you're right. It's 100 because that 11.111 wouldn't satisfy it.
Right.
Okay, attempt number 4. Sorry.
I feel your pain, Travis. I really
I
do.
lost you on number. Yeah, it's crazy. I lost you on number 11.
Okay. 11 comes out to be 20.
Okay. Okay.
Right now here.
Did you make it through 12?
We just finished 12, and the smallest that it can be is 100.
100.
The first NP comes out to be 100, and then the N times 1 minus P comes out to be 11.11. So you have to put the 100 in as the smallest.
Okay, gotcha. Okay.
So 13, is that
It's a hypothesis test.
Yeah, I'm just plugging in.
Yeah, we got that.
Conditions, I say true.
I think it's true.
True.
No.
Yeah.
Plug it in. Now the p hat would be 0.563.
I got 0.475.
I got 0.475 too.
Hmm.
38 divided by 80.
Got that 0.475.
Oh, I did, yeah. Okay.
Test statistic negative 2.282.
Is that the, let's see.
That's the Z score, isn't it?
A negative 2.684. It's 38. Are we doing 95% confidence level?
Oh, goodness.
I put the null hypothesis of 0.6 and a greater than, or which should it have been less than? Ooh.
Is it less than? I think.
I think you're right. That's
Yeah, it's less than. Does the confidence level affect this? No, it doesn't.
still the same test score, test statistic.
You said negative 2.282.
Yeah, 2.2.
Okay.
Is that what y'all are getting?
And then the p-value is.
Yeah, negative 2.282 for the Z-score.
Mm-hmm.
Okay.
P-value is 0.011.
If
Yeah.
low, reject HO. That's the only way I remember it.
Yep.
Reject.
So, sorry, 16 you had, I got a break in there,
0.011.
0.011, yeah. Use low, reject the null, 17.
Reject the null and 18.
If we reject it, then there is sufficient evidence, so it's either B or C, and
they're saying that it has decreased, right? Is that what it said?
Mm-hmm.
Yep, they suspect the water quality in the area has decreased, so it'll be the last one.
yeah, so it's D.
Darn it, and one of mine didn't save again.
Hey, I got 100.
Here we go.
100.
Hey.
You can always
Yay.
count on me to submit on time.
Yeah.
Got it.
I would submit a little bit faster if my computer cooperated.
Blaming the computer. Okay. I see now. Okay.
Not the dog eating our homework this time.
Right.
It's just slower.
I think, well,
That's all
for
right.
how long I've been in school, mine should be pretty slow right now. So I have to.
Okay, I'm going to end the broadcast. Wait, is there anything else? I think we're good.
Yeah.